All right. So let's go now to the last section that we have today. I hope it's a shortish one. Workshop 2 PM PGML. This is going to take us up to the end of PGML by telling us how MathObjects and PGML work together. So again, the table of contents and so forth. All right, so more about PGML using MathObjects and some advanced formatting. All right, so we've seen that you can provide a variable as an answer. You can use a variable that is a reference to a math object, and you can use a math object constructor directly. So we've seen these kind of things. You can have formula f, and we can get df as the function's derivative, and we can pass the formula, we can pass the derivative. You could pass a constructor directly. You could put compute here if you wanted. You could put a real number there, and you can even put real number 2 with other properties. So this one says period 10, but this is really is a element from Z mod 10. So this is a number 2 with period 10, so that 12 and 22 and so forth are all the same. So 2 is 12 mod 10 would check as correct here. And these other ones all are, given their proper values. So PGML, you can put a lot of different things in here. You can put a number, you can put a string, you can put a variable that is a Perl real, you can put a variable that is a Perl string, and they'll get parsed by math objects. You can put a math object itself like we've done here. You can put a constructor object like that. You can put a constructor with the width on it. You can put an answer checker in there, a comp from a math object, and so forth. So that's very powerful and a lot of options that you can put into here. Where is it? Next one. Answer blanks with options. So, for example, if you wanted to do an integral formula x squared, you want the answer checker for that with the flag up to constant being 1, which means that this will check for x squared plus a constant. And the problem is laid out as integral from 2x dx is something plus c, and we're looking for, of course, x squared, but I could have said x squared plus 5, and we'll get the correct answer for that. So up to constant says I'm allowed to have x squared plus anything at all. So that in order to get that into the answer blank, I've saved the answer checker that has this flag set, and I've passed that answer checker into PGML. All right. Answer arrays, I mentioned this earlier. To use an answer array, rather than just a rule, you put the star here. So the star after the answer blank says this is going to be an array of answer blanks, not just a single answer blank, and the array will be correctly sized for the value that you're getting. So a 2 by 2 matrix will get 2 by 2 square of answer rules, and the size of the answer rule is given by the number of underscores here. So you're giving the size of the individual blanks here. Multi-answer, we talked about this. I gave you one of these already. This one is being used to allow you to give the answer in either order. I get the correct and student answers. I get the individual ones out of the correct array, the individual ones out of the student array, and I say this is correct if the first correct is equal to the student's first one, and the second correct is equal to the student's second one, or the first correct one is equal to the second student's one, and the second correct is equal to the first one. So you get you check to see whether they're equal in any order. So this particular one asks for 12 and 6, but I can put it in as 6 and 12. So this gives it either order. So that's correct as well. And so is 12 and 6. Of course, you could make this more sophisticated by allowing blank answers through and checking to see if one is blank and the other one is one of the correct answers and so forth. So you can make a more sophisticated, specialized checker for that. We didn't do that here. So if you left one out, it'll say it's incorrect, and it won't give you any information about the 12. So in this case, it says 12 and something, and this is incorrect as a whole because you haven't finished answering the question. Okay? All right, so traditional answer checkers can also be used with PGML. I mentioned to you that there were, well, WeBWorK has a long, long history. It's over 20 years old at this point, I think. And so there's a lot of stuff has been developed for it since then, like MathObjects. MathObjects has not been around the whole time. It's been around for about half of the time, about 10 years, been 11 years. Things like PGML have been around for maybe 8 years. And so there's a lot of older problems that work in older ways. And the ways that you did stuff before you had MathObjects was you had individual comparison routines. So this says numeric comparison for 12, and this says string comparison for the string OK. And you can pass those into PGML if you really want to. You don't need to because you can do all of this stuff with MathObjects now, except for a few things that string comp does. There are some specialized string comparisons that are easier to do with the traditionals. But this is one that does traditional alone, so you can pass those in as well, just to give you the full picture. All right. Typesetting in PGML, we need to talk a little bit more about that. We know that you can use these algebra contexts to produce output, but it uses a special typeset context that I mentioned last week, but you might not want to use that one. You might actually want to use a context that you have declared in the problem. So if I'm using vector context, maybe I would like to stay in that vector context for PGML. So if you're going to do algebra notation, so that's the algebra notation delimiters, and I wanted to put a vector inside of there, you can put in square brackets after the algebra notation the word vector, and this will be this one will be parsed in the vector context. In the case that I've done here, I've actually set a variable equal to this context, and I could pass that variable in here instead of the word vector, and that will use this particular context. Or if I put a star here, it'll say use the current context when the begin PGML started. So context vector sets the context to be vector, so this would also be vector context. So there are a variety of ways of controlling the context that the algebra notation gets parsed in. And all three of these will produce the vector using vector notation, rather than the typeset context that requires a little bit extra work to get a vector, because it wants to allow less than sign to mean less than. So there's a special vector notation. One of the things that you want to be able to do sometimes is do these reductions. We talked about formulas where the coefficients are bad. You want to be able to do those reductions even in PGML. So here we've got these coefficients 1, 0, and minus 2 again. So ax squared plus bx plus c would normally display as 1x squared plus 0x minus 2. Turns out that plus minus gets fixed up automatically. So in this case, we don't want this 1, and we would really like to drop this term entirely. So if you put 2 stars after the algebra notation, that will perform reduction automatically. So that'll get rid of the 1 and the 0. So that's the way you force reduce. I should warn you, this is new. I just added this to PGML, so it's not in the production release of PGML. It's in the one we're using in this course. So this is one of the advantages of this course. You can get a more up-to-date copy than anybody else has. So the reduction is done with 2 stars out here. If you want to specify a context and do reduction, you can do that. Here it is in vector without reduction. Oh, math error. Great. I screwed something up somewhere. Well, we'll ignore this for now. I messed it up. So that's my editing this PGML at the last minute, and I messed it up. This is what it's supposed to do. The double stars with a context says do this and reduce it. It should have produced, well, I bet you I don't have the A, B, and C in the problem anymore because it's not here. So the A, B, and C are missing in the slide. It should produce a reduced version so that the plus 0 would go away, 1 times x would go away, and so forth. And if you use 3 stars, it's reduced because of the first 2 stars and in the current context because of the second star, the third star. So 3 stars means reduce using whatever the selected context is. So John is putting me in the penalty box for screwing up my slide. Reductions can be particularly useful in solutions, so you don't need to compute intermediate results. I've put the line break in the wrong place here, but it doesn't really matter. So in a solution like this, begin PGML solution, end PGML solution, suppose you said ax squared plus bx plus c becomes ax squared plus bx plus c reduced. We'll get rid of the things that you want. So in this solution, 1x squared plus 0x minus 2 becomes x squared minus 2. So if you want to show sort of intermediate ones where you have these coefficients in it and the results where you don't have them, you can add this reduction stuff into your solutions. Reducing forces the entire formula to be reduced. That might not be what you really want. If you're trying to show intermediate steps, maybe that would cause too much reduction. You can get only numeric computations to be reduced by setting up a copy of the typeset context with reduced constant set. Normally, typeset has reduced constants turned off so that you get exactly what you typed. You can create a copy of typeset using this by saying parser context, get copy of typeset, and then call that reduce. And in reduce, set the flags, reduce constants to 1 so that we get the flags to constants to be reduced automatically. Suppose I have a value 2 and minus 2. I could have x squared plus a plus b x plus 1 becomes x squared plus a squared plus b, a plus b x plus 1. And I'm going to use the reduce context as the context here, which means that numeric values will be combined. And so the difference between this is the following. Because 2 minus 2 is 0, that got combined into 0, but we are not reducing anything further than that. We're not getting rid of zeros or coefficients of 1 and so forth. So you might want your intermediate result to show that 2 plus minus 2 is actually 0 here. So the difference in using this reduced context that has only reduced constants as opposed to fully reducing, which is what the double stars does, is that we've left that term in there with a 0 coefficient. So reduce may over-reduce things. It may get rid of stuff you want to keep around. So you might want a slightly less reduced version, which is what this does. It just reduces sums and things, and combinations of constants, but it doesn't get rid of coefficients or other terms. So our next part is looking a little bit more closely at variable substitution. You know that you can put a variable into PGML using the brackets around the variable name, and we've seen that when you substitute a math object into a TeX expression, the math object will generate TeX form and so forth. So if I have a math object formula and I stick it inside a TeX math delimiters, it comes out as TeX. If I put it inside of algebra delimiters, it comes out as algebra and displays properly. If I simply stick it into the text with not in math mode, you get out the algebra string that you would have gotten from it. So it does what it should do, what you would expect it to do. It's also possible to do something a little bit fancier. This $ stuff can be used to substitute the result of a computation, provided that computation begins with a variable. So this is a trick. This is actually wasn't intended design, but it turns out to be useful enough that I've left it. So that if you have $A is 4, and you want to say A plus 1 is the result of A plus 1, you can actually do it here. This will take A, add 1 to it, and insert the result. So we get A, which is 4, plus 1, so there's the plus 1, and this is the value 5. So you can use this kind of substitution to get intermediate coefficients and so forth in your results. And again, that's particularly useful in substitutions, in solutions. So here you have A is 2 and B is 3. You could say, I'm going to put in here 2 plus 3 and show that. And in this one, I'm going to have the result of 2 plus 3 in this one. So here, x squared plus 2 plus 3x plus 1 becomes x squared plus 5x plus 1. So you can get that intermediate result there without having to make a whole separate variable that contains A plus B. So you can do it that way. And again, you have to start with a variable in here because it's the $sign following this open bracket that triggers this to happen. So you can't put a parenthesis as the first thing, for example. But this is useful enough to keep. You can substitute the results of a Perl command into PGML as well. So that's done using brackets with @ signs in it, and the output of that Perl command will be placed into the problem at that point. So, for example, PGML doesn't have a way to get an answer box. Answer boxes is a large square answer box rather than just a single line answer box. So this is 3 rows of 40 columns. And PGML doesn't have any way to deal with that. So we can cause it to be put in by using the open square bracket @ sign and close bracket with an @ sign. And here I've actually included the answer string to this as well, the ANTS call to associate a comparison routine to this answer box. So in this case, I'm just having it require you to type the string none in here, but you could do something more complicated for an essay of some kind here. The last thing to do, so this whole thing puts in this box and associates an answer to it by performing these 2 Perl commands. The last thing is this star. Normally, the result of a substitution will have its values inserted so that you see every character that was there. In this case, answer box produces HTML already, so we don't want that to be modified and turned into things that we see. So we put a star there to prevent PGML from modifying the results. So the answer box sticks its value directly into the problem at that point. This is particularly useful in solutions. Again, if you want really the most fine-grained control over the reductions in your solutions, you might want to say 3 minus the value of A squared is X, and you might want to say, you might want the result of 3 minus A to be squared without reducing the square as well. So we could say, in this case, 3 minus 5 squared X becomes minus 2 squared X, as opposed to trying to use reduce on this, which will take 3 minus 5 and, well, that should have been square brackets around that. It would take 3 minus 5 and then square that. The reduction would say 3 minus 5 is a constant, squaring is a constant, so I should reduce all of that to the number 4. So if you want to see the minus 2 squared first, you can force the result to show up here by performing the computation here in Perl, having that inserted into the middle and not doing any reduction on it. So you can force particular computations to be performed in the middle of the mathematics, again, without having to perform individual variables. You could have set a variable to that value and inserted that variable here, but then you get all of these extra variables that are unnecessary in the problem. So you might as well just do the computations. escaping substitutions. I mentioned this a little bit with the stars, slide or two back. Normally, when a variable or command is substituted into a problem, it will be inserted so that all characters in the substitution appear. So, for example, in PG, the variable b small will contain either HTML or tech that will cause the stuff between there and e small to be in small letters. And this says insert that variable into the PGML. But PGML makes sure that whatever is in that variable gets displayed. So if we were to simply do this, you would see the command in HTML that would cause this to become small, and the command in HTML that would end that. And this gets displayed verbatim. You don't have the action occur to make it small. You see the actual HTML code. That's what happens if you simply insert this value into there. That's because PGML wants to show you exactly what this variable contains. If you say, no, that variable contains formatting commands that I want you to actually respect, you have to put the star after it. This says take the results of this and don't do anything to it. So here, the word small actually is smaller because the begin and end small tags are inserted into the output without making it that they're visible to you. It makes it so that they do what they're supposed to do. So if you want to use one of the PG variables that does this stuff, you can. You simply insert it with a star after it. And we saw that in the previous slide. The command that produced answer box was something that has these kind of HTML tags in them. And so you want them to have their effect rather than be displayed. So you use a star after it to do that. Substituting PGML into PGML. Well, it's possible that you have a variable that contains some PGML, like this math block in here is assigned into X. Well, if I simply insert X, what I'll get is verbatim those characters. So they will not do what they're supposed to do. And here is begin bold and end bold in the PG style, not the PGML style. And that gets the actual bold characters. Well, if I say, no, I want the value that I've got in this string to be inserted directly into the file, we'll get the bold to have its effect, but this PGML stuff will not get performed. 2 stars after it says, continue to process the results of this as PGML. So that would say, make this math be math, and there it is. Unfortunately, that also makes this stuff no longer be bold. It says, process this as you would have in PGML, which would say, show those angle brackets and characters. So there are 3 different ways this gets done. Exactly what's in the variable, used verbatim into the output, or continue to be processed as PGML. So depending on what you've got in your variables, you can control how that works. There's one more substitution, which is substituting LaTeX into PGML. Because PGML doesn't use the standard LaTeX delimiters like these, and a lot of WeBWorK, well, a lot of PG produces things that have these in them, you may get a character string that has LaTeX stuff in it. So here's a character string that has LaTeX delimiters in it, and if you wanted this to actually produce math in your PG, you want to put 3 stars after it, which says process the results for LaTeX. So this will get inserted in, and then this will get processed not as PG math, but as LaTeX math. So there you go. And that works with commands or variables. So some commands that get produced by if you're doing @ signs around some commands, and those commands produce old-style LaTeX delimiters, you may need to put stars around it to get them to display properly. I think I have 2 more slides here and we'll be done. You can use vertical bars inside here to get verbatim text that is inside those things, no PGML commands will be interpreted. So inside here, even though there's something that looks like math mode, this will not get performed. We see that verbatim. We see that exactly as it was typed. So you can avoid having PGML process things by using verbatim mode. And if you want to have verbatim mode inside verbatim mode, you put more vertical bars around it. So as many vertical bars as you want, so I could put verbatim inside of verbatim mode. Again, you're never going to do this, but it's there. If you want the verbatim content to be shown in a monospace font, put a star after it. That'll look like a command that way, different from the rest of the text. And finally, at long last, pre-formatted text. If you want, for example, code or something else to be inside here, you start it with a colon and 3 blanks. So this will keep the line breaks where you want, and you'll see them in a monospace font, but commands and other markup are actually performed, and things like the special characters are properly quoted so that they'll show up directly. So other markup are controlled in there. So if you want to prevent that, you could use verbatim mode inside of pre-formatted. The pre-formatted is only saying line breaks and indenting, and that stuff is retained. Or perform normally. So something is wrong here because I got an extra line break. So something screwed up there. If you want to have pre-formatted lines inside of indented stuff, you can do that. All right, I think that's the end of us for today. That's the title page for that. So that finishes up the advanced formatting in PGML and the connections between PGML and MathObjects. Perform normally. There shouldn't be a blank line here. Should not be a blank line there. It should be indented, but it's not. But it should not be a blank line there. It should be a line break and indentation, but not a blank line. This is again to Tim. Tim is asking, what if I wanted a line break but still maintain the list format? This is not a list. This is pre-formatted text. This is not a list. This is lines that have a certain amount of indenting given by how many indents you have given here. Are there 2 lines, 2 spaces up here? That's probably a bad interaction. That is true. Yeah, I guess you could read it that way. That forces a line break. Sure, why not? Because other markup is being performed. So if I got rid of those, then it should close up. Thanks. It's somewhat like verbatim LaTeX, but not entirely, because commands are being performed here where they would not be in LaTeX. So just like this is performing bold, whereas in LaTeX it's not. These things are for formatting, keeping the line breaks and the indenting the way you have it. That's all. It doesn't prevent anything from happening. The ones that prevent stuff from happening are these. These are the ones that cause commands not to be performed. So they're separated. Those 2 ideas are separated. Syntax highlighting, no. We don't have a means of doing that currently. You can always write an extension to do that if you want. No, we don't have any of that. This long predates anybody having done that in web pages. One thing I was not clear about is, were you talking about actual lists, or are you talking about, if you're talking about a list like this kind of a list, you can have this list have spaces between it in this way, and this is still okay, even if there's a numbered list. It should be okay. So you can certainly separate list items in this way. That could be a solution as well. I'm not sure I get to do solutions here. Can I do that in this lab or not? Yeah. So that works in solutions. How could I change the vector context globally use parentheses instead of angle brackets? Is this possible? Yes, it is. It's a little bit complicated, and this is one of the uses of PG course.pl. And in fact, if I'm not mistaken, the PG course.pl that's in macros library, in the macros directory, actually includes the code for doing that as a comment. So here is what you would need to include in your PG course.pl file, or in the customization parser customization file. So this makes a copy of vector. It really what it does is turns everything into points. So it allows vectors to be promoted, to promote points to vectors, and it lets vectors use open and close parentheses for what they produce. All right. So there are a couple of macro files that we try to load all the time, like PG course. So that's a place this could go. But I knew people weren't going to stick that into their files. So there's one called parser customization.pl that you can also use that gets loaded every time MathObjects.pl gets loaded. So that is another place you can do customization on a course-by-course basis. If you make a macro file and put it in the same directory as the problem files you're working with, that won't interfere with anybody else's stuff.